In this video, we're going to look at some of the unit conversions of angular velocity that we'll commonly deal with in the engineering dynamics unit. We're looking particularly at converting between RPM and radians per second, and also between revs per second and radians per second. I want to look at 4 examples. And deliberately, the same value has been chosen for examples B and D to show 2 different conversions of rads per second into revs per minute and to revs per second. But let's take example A first of all. So in example A, we have a conversion between revs per minute and rads per second. What the course notes tells us when we're dealing with such a conversion, our formula for converting is the second one in the red box. So we have this formula here. Now when we use this formula, the value omega is going to be our value in rads per second. So that's the thing we're trying to find in part A. And the value n is going to be our value in RPM. So here we have n is 200, RPM, omega is unknown. So we put the value we do know into the formula. So we're still left with omega is equal to 2 times pi times 200 divided by 60. And if we put that all into our calculator, what we're going to get here well, the calculator might show it's 20 over 3 pi, but in decimal form, it's going to be 20.944 radians per second. In part B, we're being asked to do the opposite conversion. So in part B, we need to use the same formula. We need to use omega is equal to 2 pi n over 60. But this time we've been given omega is 35 radians per second, and n's are unknown, the value in RPM. And we can use the same formula because although we have a different value, we're substituting in the different part of it. So this time we have a value for omega, so we put our 35 in here. Last time we didn't know that. And we have 2 pi n over 60. This means that to find n, we have n is equal to 35 times 60 divided by 2 pi. We can multiply both sides by 60 and divide both sides by 2 pi to get n on its own. And we can put this into our calculator. And that gives us a value of 334. If we just keep rounding to 3 decimal places, 0.225, but generally with RPM we'll round to the nearest RPM or 1 decimal place, but RPM, which we can also write as rev / minute. That's the same units there. So we've happily we've done parts A and B. So let's look at part C. We're asked to convert 75 revs per second into rads per second. Well, in part C, we're using a different formula, and I'll just bring down our questions and our formula sheet. Bring down questions C and D here. So we want to use our first formula in this case, because the first formula tells us that's what we do when we want to convert between rads per second and revs per second. So this formula is given by omega is equal to 2 pi n. And in question C, we have n because n is a value in revs per second, 75 revs per second, and omegas are unknown. And a little bit less work to do because we'll have this 60, which would be converting in minutes and seconds. So we can put in omega, which we still don't know, equal to 2 pi times 75. So without putting it into my calculator, I'll say that's the same as 150 times pi. And solving that, we get 471.239. 3 decimal places, radians per second. In part D, again, we're working between radians per second and revs per second, but this time we're converting in another direction. So it's the same conversion formula as part C, but this time we know omega, it's 35 radians per second, but we don't know the lowercase n, which we want to find out in revs per second. So we substitute our values in. 35 is equal to 2 pi n, so n is equal to 35 divided by 2 pi. And solving, we're left with 5.570, and that is in revs per second. So that's our 4 conversion. That's an example of the main 4 types are ever going to be asked. So the main conversion we deal with is the types in part A and B between RPM and radians per second. Just a quick look, if we look at part B, with our 35 rads per second into RPM, we multiply by 16 divided by 2 pi. To do the same thing into revs per second, we just divide by 2 pi. And that's because the 60 comes from converting it into per minute rather than per second. So that's a difference between the 2 formulas that we're using. But we don't have to think about that if we remember to use the formulas and put in numbers correctly as in the examples here.